Good morning, everybody. I'm Alvin from Pedina. Let me get the box. There we go. Today I'd like to talk to you a small presentation about proven approach, project delivery best practices. I'm Alvin. I'm a software and cloud architect, a full stack developer, cloud engineer type person. I'm very interested in this kind of DevOps type approach that has been coming across the past few years, about getting software out the door quickly, safely, reliably. So this is what I'm all about. So I work in Pedina, and we are a consultancy. We're here today. We create custom applications, custom solutions. Cloud native is our kind of focus. But we've got a good heritage in Java, hence why we're strong partners of Magnolia. And indeed, thanks to Magnolia for having us here today. It's a great honour to be here and to be first. And as they say, kind of first is best, or save the best till first, as they say. So yeah, I'll take you today on a bit of a journey of kind of an idealised kind of software project that we may expect to see. Include things like the contractual side of things. The kind of the requirements engineering, some bits about the agile design and build process, the architecture, and ending up with the DevOps type side of things. I've only got 20 minutes, so apologies if I'm rattling through somewhat. We'll be around. We've got my colleagues here. We'll be around outside, so please come and have a chat to us later on. So first of all, cost model. So, what is a developer up here talking about cost models for? So this is quite pivotal to actually how we manage to build our software and get it out the door. And we need to choose the right kind of model for the job. So first of all, fixed price. We all know and love it. It needs no introduction. Well loved, and it's perfect. It's a really great model, especially for any kind of assembly line type solution. So anything that you've done many, many times, hundreds, thousands of times. You've got the costs, you've got the materials. It's understandable. You put the numbers in a spreadsheet, and you've got your result. The problem starts to come, and this unfortunately kind of often happens. We have someone come to us and say, "Look, we want a solution for X, Y, Z. It is potentially a little bit maybe poorly defined, poorly understood," and they say, "Give us a fixed price, and by the way, we need it next week." So that's a bit of a troublesome thing for us to have to deal with. As you can imagine, and not to mention, as we all know, just the idea of cost estimation and effort estimation is kind of really riddled with various issues. It's very hard to do. So if we follow down this path, then we're kind of boxed in. We're restricted by this by this scope and by these things. They're not really the fertile conditions needed for these kind of modern solutions and approaches to emerge. So the kind of alternative here is this kind of more of an agile approach, or agile scoping. So this fits well and marries well with the approach that we're going to take, and that I'm going to talk about later. It's kind of more of a pay-as-you-go type model, and it's understandable that people might get a bit nervous about this, but our approach to this is to kind of slowly kind of build trust, kind of this mutual trust. It needs to go both ways. It's potential issues on the client side and the vendor side. And it's about kind of creating those POCs, MVPs, kind of building up step by step, and kind of building that trust. So again, a good example here is for example, you imagine like a fixed price project. You maybe started whenever it was, maybe last year, and then a few months into the kind of maybe a 2-year project, this little thing called AI comes around. You may have heard of it, and this is massively disruptive. And if you're in your kind of fixed price type model, this is very restraining and restricting. If we follow an agile approach, then we can kind of pivot and move to these new technologies. So the idea here is getting things to market really quickly, getting your time to market, and this is the kind of the objective that we want to follow. And one good example that we're kind of quite proud of in Pedina is the German government coming to us in the height of the pandemic and saying we need an understanding of our intensive care beds across the country, as you can imagine. And then so we went off and within within a little while. So we designed, built, implemented, and got it running within 2 weeks. And as you can imagine, this is going to be very useful at that time when kind of time was of the essence. So we kind of set the foundations for our project. So we can now kind of start to set the scenes with requirements engineering. So this is fundamental, this is critical. Getting this done well is going to massively help and be beneficial to your project, and doing it again poorly is going to give you issues and challenges. So first point to mention here is user requirements engineer. I mean, this is their job. If you can take advantage of them, brilliant. We have them in Pradina, and especially for big projects, they're super useful. The next point is when you're doing your requirements solicitation, don't just include the business domain experts. Include the implementers, the architects, the UX designers. When we have a set of requirements that have come just from the business domain and the POs versus a collaborative set of requirements, the difference is night and day. And especially the kind of the UX designers, ultimately what we're doing is we're building software, we're building things for users at the end of the day. If we can manage to focus the requirements around the user from the beginning, from the conception, this is a real massive benefit. Include the why. So obviously we're told what to do, but sometimes the why is left out. So when we come and ask the question later, we think, oh, perhaps there's a different way of doing that. Perhaps, for example, there could be a requirement to store some user data. And then later on we figure out the why is because, it's for some analytics. And we'll then say, oh, well, there's maybe different ways of doing that. We don't need to worry about all the kind of GDPR stuff around holding user data, etc. Iterate and evolve these requirements. So that I think the goal here should be to be getting an outline of your requirements. There's kind of no need to be getting the whole set of requirements done and complete before moving on to the next step. We want to get a good outline, and we can start in parallel things like design, POCs, etc., and having these working pieces of software, even if it's just a skeleton, is so much more useful to the requirements process and the overall kind of design process than seeing some requirements on a Word document, for example. It's really super useful. And so please, we take this approach of not having to complete it in a kind of a waterfall model. We expect requirements to change as the market changes, as technology changes, as our understanding of technology changes. So we need to kind of embrace this kind of model of things kind of evolving and moving. So now we've got a kind of the scene is kind of set with our requirements. We can talk a little bit about the kind of design and build type stuff in a kind of agile approach. First point, proof of concept. This is an approach that we do time and time again, and we really love it. It's about getting, like I said, the basis of your system done really quickly, so that it can, the outcomes of that can be driven back into your requirements and into your design, getting some feedback from the users really, really super quickly. It's also about getting the hard stuff done early on, getting that upfront work. So you're not leaving it till last, which is always the temptation. Get the easy stuff done first, but it's always good to get the hard stuff done first. Defer commitments. So we should be following a lean engineering approach. So if we can at all defer any kind of commitments to later on and keep ourselves flexible and free, that's really useful. No big bang deployments. So we've probably all been in a situation where we've got a big deadline to release some software, and as often and always happens, it's a struggle, and there's things haven't been completed, and there's bugs, and testing hasn't been complete, and you do massive heroics, and then you get something across the line. The aim here is to kind of do deployments in whatever fashion with as little fanfare as possible. The aim here is to be kind of stress-free. This is the objective as possible. One kind of good example here is when we worked on a Magnolia project for BCA, actually. Instead of wholesale replacing their website with the new Magnolia website, we did it piecemeal. So, for example, we're using a gateway technology like Azure Front Door to be able to say, let's just route one page one page to the new website, whilst the rest of the web page is still being served by the old system. And this way is massively beneficial. We can build out the full tech stack, worry about those things that we don't usually do and leave to last, backups, monitoring, disaster recovery, get those done really well on a simple system, and then start to build up and iterate from there. It's a really powerful approach. And like I said, there's no big deadline, there's no big bang deployment. I just want to quickly mention about this Pradina XDD methodology that we have in-house, experience-driven development, we call it. And essentially what we've done is, when we talk about Agile, usually we talk about this kind of third module, which is kind of the building part of software development. But what we've done is we've kind of encapsulated the full process in a kind of Agile approach. So you can see from strategy, so like getting the requirements and doing the design and then doing the building, and you can see them flowing in from one to the other in this kind of process. So a few little points on architecture. A lot of this stuff you may already know, but it's always good to kind of go over a little bit. KISS, keep it simple, stupid. This is a kind of a fundamental principle of engineering. And it's amazing how often we fall into the trap of not doing this. I've done this, especially as a junior. I've literally made entire CMSs and completely regret it. But now, being a bit older and wiser, you can really kind of get behind this principle. It's really kind of very powerful. Go for architect, design, and build for today's requirements. There's always a temptation to think, there's something in the future that we want to build towards, and so let's start building that system now. But the best approach here is to just get the MVPs out the door. Don't worry about what may be coming in the future. This is the way to go. Don't contract microservicitis, as I like to call it. It's potentially a bit of a contagious disease. So microservices, lots of kind of fad and architects and systems going and using this approach. But ultimately, if you have the same kind of use case and circumstances, for example, Netflix, that's fine. But maybe if you're not, then perhaps more of a traditional type system is maybe the way forward. And lastly, here in architecture, boring technology. I mean, this is not fancy. This is not cool, I guess, but it's kind of the best way forward. It's always tempting to use this kind of cutting edge technology, but ultimately we have so many kind of stable, mature systems like Magnolia that we can leverage to build our solution. So this, again, all these kind of really kind of temptations that we must kind of resist when we're doing our design and architecture. And lastly, I'd just like to quickly talk about a few points about this DevOps approach. I think it's a very misunderstood topic. I think a lot of people think of it as just kind of modern operations, whereas I think the reality of this is it's about the people and the process. And the technology is something that emerges from this process, from this mindset. It's about breaking down the silos. So obviously the clue is in the name here. Traditionally we have the dev and the operations, and they throw the ball over to each other, and we get all the issues as we've experienced with that use case. But it's about bringing them together into the same team, and anyone who else is required into the team, and empowering them to provide the product and the solution that is required, giving them all the kind of authority and responsibility required to do so. This is, again, a really kind of powerful approach. I like to think of DevOps as the scientific approach. It takes what we've done in the past and says, is this the best way? Is there some issues here that we can kind of critically analyze and kind of think of a better way? And out of that comes this kind of DevOps type approach. And And lastly, I just want to quickly talk about the free ways. I always recommend a fantastic book called The Phoenix Project, which talks about the DevOps kind of movement in a novel form. And in there, they talk about the free ways. The first one being the fast flow of work. So this is about getting your work from ideation to production super quick, as fast as possible. The second way is about getting feedback and amplifying feedback loops. So when you do an action or a change or something, you're getting the result, whether good or bad, quickly, rather than in 3 months' time when you're on holiday and you've forgotten about what it is you did 3 months ago. And lastly, having this idea of a culture of experimentation and learning and continually improving. And all these three things together kind of encapsulates this DevOps kind of movement, and if done properly, is, like I said, really super powerful. So hopefully I haven't overstayed my welcome and the time available. Thank you so much for listening and having me here. We're available all day long. If you agree with me, if you disagree with me, cool, let's come and have a chat. We'll be out there and we'll be happy to chat and talk. So yeah, thank you very much.